anytime. Okay. Entonces, I try to say que the first standard logarithmic we study today is called common. And common, the base is 10. And important to understand that when the base is 10 of the any number, you can write like that. So omission this number that normally we write when you see in the algebra language, you see get missing nothing, is because we are talking about common logarithm base 10. And this is this key. Look at that. Do you see this key? LOG? Okay, don't worry. Relax. Only pay attention and try to understand. Okay, now, the second idea is, the second standard, que es important, is natural. It's natural logarithmic. Natural logarithmic, the base is one famous irrational number that is called E. I want to explain who is E. And the notation is approximately equivalent. Suppose you have logarithm base E of the any number. Entonces, normally you write like that, Lm of x. Entonces, default, this notation, Lm is equivalent to say logarithm base E. And definition of E, well, it's irrational number. Now, wow, it's irrational number. It's irrational number E. Is equal, okay, maybe you don't understand very well, but I need to write like that. It's limited when the x approaches to infinity of the one expression gets 1 plus 1 over x raised to the x power. So basically it's one expression like that, 1 plus 1 over x raised to the x power. And this operator indicates that you try to evaluate in, a huge number. So suppose que 1 over 10 raised to the 10 power. No. 1 over 100 raised to the 100 power. 1 over 1,000 raised to the 1,000 power. Something like that. So this number increasing forever. And when you compute this, approach it to E, and the approximation value for the E is 2.7182818. And this is continue forever, infinity decimal place, because it's irrational number. Okay? But don't frustrate with this. You say, well, professor, what is the reason that we have two kinds of logarithm? What is the reason that we have two kinds of logarithm? This one and this one. Well, because maybe no. And normally in science, chemistry, physics, we using common. Okay? However, in calculus, the student can need to take calculus using natural. Maybe you don't understand very well what are the differences now, but I guarantee you that in calculus it's very, very advantage using natural. For some reason that you cannot understand now. It's beyond the scope of the course. Okay? This is the idea for the standard. Okay, then how are we using this in the real life? When are we using the standard logarithm using this property? Let me study now property. Property property, okay, properties of logarithmic. Okay, look, we study now 8 important properties for the logarithm. 8. Okay, we're using every day from now. Number one is logarithm of the any base of 1 is 0. You know that. You remember that. So that means, for example, suppose you compute logarithm base 2 of 1 is 0. And logarithm of the common base, que is 10, when it's 10, default, you don't write the number here, is also 0. And logarithm natural of 1 is also 0. And we can verify in your own calculator if you want. It's okay. It's okay. Number 2 property, que es important. Logarithm of the number inside the argument is exactly the same with the base. The answer is 1. For example, logarithm of base 2 of 2 is 1. Logarithm common of the base 10, because the base is 10, is 1. And LM of E is 1. Entonces you see, bueno, where can I find E in my calculator? Well, remember, in my calculator, let me make it zoom to see the calculator. We have 2 important keys. This key is common logarithm, and this key is natural logarithm. And in the top part, in blue color or in yellow color, depending on the calculator, we have the exponential associated with this. So when you press directly, this key is LOG. When you press directly, this key is LM. However, if you press second key first and press this key, now we have the exponential associated with this. Okay. Likewise, if you press second key first and press LN key, so we compute e to the x. Suppose I want to investigate what is the value for the e. Well, you put e to the 1. Is 2.71 something. Okay. We practice. Don't worry, we practice with the calculator. The third property, number 3, is when you put together logarithm and exponential. Look, logarithm of the any base of the one exponential is equal identity function. What's the reason? The reason is because logarithmic function and exponential function are inverse function. And when you composition both together, it doesn't matter the order is not important, undoes each other, and the answer is identity function. For example, logarithm of the 10 to the x is equal x. ln e to the x is equal x. log base 2 of 2 to the x. Guys, it's important that when you write the function logarithmic log, you open the parentheses and you put inside the argument of this. Okay? Why? Because this is the function notation. Suppose you put f of x like that, f of x without parentheses. Have no sense, right? So now always when you put, some people, I don't know why, I forgot and omit this logarithm 2 like that. Everyone understand very well. However, much better, more clear, more properly is enclosing the parentheses. Okay, number 4 property is similar, but we are doing in opposite direction. So you put the exponential first to the logarithm of base a of x, and the answer again is identity because undoes each other. Okay, example of this is, suppose 10, exponential first, 10, the base is 10, raised to the log of x is equal to x. E to the ln of x is equal to x. And base 2, okay, 2 to the log base 2 of x is equal to x. This is equal to x. I forgot this. This is a property number 4. And this is a property number 3. Gets the same, but the only difference is you apply first the exponential. Remember the notation for the composition. We have one function first and one function second, no? In this case, the first is the exponential and the second is the logarithm. In this case, the first is the logarithm and the second is exponential. But it doesn't matter the order because I know that f composition f inverse is equal f inverse composition f is equal identity function. This is no surprise for us. Okay, now we have 3 more property. 5, 6, and 7. Okay, in my opinion, is the most important property. So when you have, for example, logarithm of the any base, and inside the argument we have 2 expressions, m times m, we can separate like an addition plus. This is very useful because we can do in that direction or in that direction. In that direction, you expand the logarithm, only one logarithm in 7 logarithm. In that direction, you condensing several logarithms. Suppose you have 2, 3, 4, 5, and you condense it in only one logarithm. This is very, very, very useful. We are using every day from today. This is number 6 property. Number 7 is when it's division. It's similar, but inside the argument you have division to expression. So when it's division, you're subtracting. You put expression on the top like a positive, minus the expression at the bottom like a negative, subtraction. And this makes sense because, you know, the logarithm working as exponent. And you remember the rule of the exponent. When it's multiplication is addition, the exponent. When there's division and subtraction. And 7, when it's the power of the power. So you have logarithm base 8 of the m raised to the r power. This power you put in the front as a factor times logarithm base 8 of m. And this property number 5, 6, and 7 we using for manipulate the equation, the exponential equation and the logarithmic equation that we study. No, I don't know si today we start at least one. And finally, the property number 8. Wow, it's the most important property. And receive a special name. The name of this property is change of base formula. Change of base formula. And this formula allows us to compute any logarithm. Remember in the last class, we compute the logarithm using the intuition without calculator. But today, no. Today we are using the calculator. Okay, entonces what is the formula? Well, the formula is, look. The formula is, you have logarithm of the any base of the one expression I want to call x, expression or number, is equal the division to logarithm. And this logarithm contains new base. So b represent the new base. I want to change because I want to change from a to b, no? So this is the old base and this is the new one. And you put exactly the same number here, xx, and here you put a. This is the formula. Let me try to illustrate the application for this formula using one example, no? Okay, suppose que in the last class we compute logarithm base 3 of 81. Okay, I don't know what's the answer. So we are doing in that way. Look, I convert to exponential. For me, it's not clear logarithmic so far. However, exponential is clear for me. Okay, so you translate from logarithmic statement to exponential statement, and the base is 3. So this small 3, can you see here, represent the base, and the base is 3. You put a base, and the exponential gets a big 3. The exponent is the answer for the logarithm, and the result is 81. I try to manipulate 81 using common base, que I know gets 3 to the 4th power. Then when you have two exponential and the base is the same, it's because the exponent is the same. And this is the way we are doing so far to compute the logarithmic. Now we have calculator, and in the calculator, of course, we can compute any logarithm. But the problem is that our calculator bring me only a standard, and 3 is a non-standard base. It's a non-standard base. But don't worry, because we have in my hand one magic formula can allow me to change the base. Suppose that, again, I want to compute a logarithm of base 3 of 81. However, mentally, I convert to a standard base. And remember, we have two standards, LOG or LM. Suppose I like LOG first. You put it here, LOG 81, okay, the same number, look, XX, and the new base, so the old base is 3, A is 3, now the new one is 10, entonces when it's 10, no necessary specification, no, nobody specification, because everyone suppose default, que es 10, no? And logarithm base 3. Okay, and you put in a calculator. Calculator now. I try to explain. Unfortunately, the emulator doesn't work. But okay, don't worry, be happy. Everyone press the key LOG. Okay, you suppose that this is the display of the calculator. I press the key LOG. Yeah, you see in the display something like that, LOG. Automatically, the calculator opens the first parenthesis, and you put 81 and close the parenthesis. So I did that part. Division, 81, close the parenthesis, press division key. And I press the bottom part, que es LOG again. I press 3, close the parenthesis, 3. Close the parenthesis and press enter. Bang! And the answer is 4. Exactly the same of this. Okay, entonces now, so far, you have no excuse to compute any logarithm because we can do using the calculator. And normally, well, depending the problem, no? The base is a standard or non-standard. Si it's a standard, yes, it's nice. You can put directly in the calculator. Si it's non-standard, we're using the chain of base formula, no? To convert from non-standard to standard logarithm. Okay, I have a question. Suppose one student say, Professor, well, okay, I understand that. However, I can compute the same thing. Use a natural logarithm like that. ln of 81 divided by ln of 3. Come on, try in your own calculator, please. Come on. Try. Caroline, John, Yulisa, Ruby, Annie, Hannah, Hanael. We have Hannah and Hanael. Wow. Michelle, Sabrina, Gabriel, Marissa, Taylor, Rosemary, Delilah, Kathy, Yanelis. 4. Sabrina say, I got it. I have 4. It's the same answer, right? So basically, the only thing I did was the conversion from non-standard, que es base 3, to standard, pero it doesn't matter what standard I select, or natural or common, and the answer doesn't change. It's the beauty. Super. Okay. So I propose you now. Using the property of the logarithm that we studied so far. To do some elementary example, for example, how you expand or condensing. Suppose that we have, for example, this example. This example is good. Suppose that we have two logarithms. 3 times logarithm base 6 of x plus 5 times logarithm base 6 of x minus 6. And the question say, express this expression as a one single logarithm. So I want condensing these two logarithms in only one. Important. When you condensing the factor in the front, you express it like an exponent. So basically, we use in this specific example the property number 5, because I can see a plus, when a plus is multiplication, and the property number 7 is when you have the factor in the front, you put it here. Okay, now the answer is only one logarithm. By the way, the base of the logarithm should be the same, must be the same. See, it's different, no, we cannot apply the property. The property is only applied when it's the same. Then we have x times x to the third power, because this is the exponent here, multiplication times x minus 6 raised to the fifth power. This 5 to the fifth power, and everything enclosed in the parenthesis. Remember, this is the parenthesis que indicate the argument for the logarithm. Okay, this is in one direction. In one direction que es condensing, no? However, we can expand. For example, like that. Suppose that we have ln, natural, of the one expression que es m to the fifth power times m to the 8th power divided by x to the 6th power times y to the 7th power. And they want completely opposite, right? As a sum of difference of the logarithm, express the power as a factor. Okay, they want you opposite direction, you expand. So we expand this only one logarithm and 1, 2, 3, 4 logarithm, right? And you apply, in this case, the property number 5, because you see time multiplication. The property number 6, again, because you see division, look at that. And the property number 7 can allow me the exponent put in the front as a factor. So it's easy, you put ln of m multiplication by 5, because this 5 gets the exponent go to the front as a factor. Plus, so everything in the top is positive. 8 times logarithm of m minus everything in the bottom is negative, 6 times ln of x minus 7 ln of y. That's it. It's super easy and super useful, because we can use it right now in the solution for the equation. Do you understand the idea, or it's confusing? Clear, confusing? You remember, you don't remember? You see in high school or no? Come on. I want to know, feedback. Tell me, everything okay? You follow me? Confused. What part confused, Sabrina? Come on, activate the microphone. What part is confusing? Come on, I need to know.
The way that you switch the formula.
What formula? Okay. No, it's easy because when this plus, when it's plus here, plus, is multiplication. Suppose another example. Suppose another example. I have a lot of here. Pero I suppose que es easy. Pero I suppose que it's not easy, no? Okay. Suppose this example. Let's do one similar example to the first one, in which you have several logarithms, and you condense it in only one. Suppose a times ln of x minus 12. This is one expression. Minus 3 times ln of x. And the question is say express it as only one. I don't need two. No, two no is no good. Only one. So you condense it. What property you apply? Property 6 and property 7. No 5. Why no? Because it's minus. When it's minus, it's 6, que es division. So you copy only one ln, because the idea is condensing only one. And the top, you put the positive part, is x minus 12 raised to the a power, because there is fly to the power. And in the bottom, we have x to the cube power. Everything enclosed in the big parentheses. More clear now or no? One more. One more in the opposite direction. Oh no? Sabrina, it's okay? Yes, please. Okay. Look, Sabrina, another. Let's do another, for example, Sabrina. Okay, suppose that you have log, so inside the parentheses you have 9x over 2, no? And again, we have to separate in several logarithms. So you expand this. The mathematical operation in between 9 and x is multiplication and divided by 2. So you separate logarithm of 9 plus logarithm of x minus logarithm of 2. Why minus? Because it's division. Division is minus and multiplication is plus. In this case, no exponent. Okay, nice, no problem. And the base is completely missing. It's because I suppose que 10. I suppose que we are working with the common logarithm. Confusing now or clear? Clear. Okay. Entonces, this is fantastic, guy. I want to illustrate why. You see que no, it's a little bit mechanic, professor. I don't see where's the application. You see now the application. Let's go again to the exponential equation. Okay, one more time, professor. Well, okay, remember we have the regular exponential equation. For example, easy. Come on.
Oh, sorry.
Okay. Pulling off the microphone, please. The regular exponential equation, the regular is the exponential equation like that, 2x equals 4, pero I know that 4 is 2 to the second power, therefore x is 2. Okay, this is the regular in which you manipulate both sides in order to express it using the common base. And when you have that, see the exponential is the same and the base is the same, it's because the exponent is the same. However, we have a special exponential. In the test, you see regular and exponential. So one question or two questions for the regular and one question or two questions for the special. Suppose we finish the last class, try to solving this equation. In this case, impossible. It's impossible to express 3 using base 2. No, it's impossible. However, we study logarithmic for solving this and another more complicated equation, because we apply logarithm on both sides. Well, okay, you apply logarithm on both sides. What kind of the logarithm? Either you can use I recommend standard. Because finally we ending using the calculator, no? maybe LG or LN, doesn't matter, the answer doesn't change. Entonces, in this moment, pay attention, you apply the property number 7, que the property number 7 allow us que this exponent go to the front as a factor. You copy x times log of 2 equal log of 3. Okay, property number 7 allow me the exponent fly and put in the front as a factor. And this is really, really, really amazing. It's really magic because the logarithm allows us convert from this equation, que is exponential, because the unknown is located in the exponent, in another equation, que is no exponential, it's linear equation. It's linear equation. Maybe the student confused a little bit with the logarithm of 2, logarithm of 3, what the hell is that? No, suppose you omit the word log, 2x equal 3. This is a linear equation, yes or no? Absolutely, this and this is not the same. But logarithm of 2 and logarithm of 3 is just a number that we can compute in the calculator. So finally, you divide both sides by log of 2, like a linear equation solution. And x is equal log of 3 divided by log of 2. And end the story. We finish. Almost we finish. This is the exact answer. Okay. However, in the test, normally we want the approximate answer. Well, okay. I put in a calculator and end the story. Come on, guys. I try to do, and you try. I wait for you to the answer. You put in a calculator, log, press the famous key log of 3, divided by division, log of 2, again the same key, of 2, close the parenthesis, don't forget, press enter. I get the answer. However, in the test specification, I need 4 decimal places, or 3, or I don't know. Entonces, you need, for example, I want to copy. Come on. What's the answer you get in your own calculator? Come on. Caroline, you have calculator? Yes or no? Eso, bueno, Sabrina. Nobody have calculator, only Sabrina. Okay, John. Okay, John say, Sabrina say, que the answer is, I want to copy the answer I can see now in the display of my calculator. 1.58, 49, 62, 50, and 1. Depende de calculator. Some calculator offer 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal place. Another calculator offer less or more. However, I need 4 decimal place. 1, 2, 3, 4. To say you round, the process of round, you need to know when this digit after the 4 decimal place is greater than or equal to 5, you increasing. So actually, this is around 1.5850, no? Because 49 plus 1 is 50. And this is my final answer. Any question? Okay. In the special exponential equation, normally the solution is irrational value. This is irrational. This is irrational number. The majority irrational number. The majority of the logarithmic are irrational numbers. So I have infinity. Now you need to truncate or round to the specific decimal place in the test say. Can you also write 1.55? No, si es 58. Es 1.58. 49 and 6. Entonces, Okay. Suppose que 1.58, 49.3. What is the difference between this guy? This guy is bigger than 5, bigger or equal 5. Therefore, you increasing. You increase 9 plus 1, is 10. And 10 entonces, actually 49 plus 1 is 50. Suppose que this case is less than 5. Entonces, no, es 1.58, 49, stay the same, don't increasing. Okay, pero no, never 55. Hello, what the hell? 55, no? Okay. Clear or confusing? Huh? Okay, sorry. Okay, good. Okay, let's move on to the second example. So we are working now with the exponential equation that we can never solve it by the traditional way. What is the traditional way? Manipulate both sides in order to express the same base? No. Now I realize that this is special, and your only possibility to solve this is using logarithm of both sides. Okay, suppose this equation. Okay, my recommendation always, when you face one equation like that, there are several ways to do. However, my recommendation is isolate the exponential part. So you divide by 5. This is highly recommended. 2 to the x power is equal a over 5. So this is a crucial moment in which you apply logarithmic. What kind? Of course, standard. I don't know, some people prefer log, some people prefer ln. Doesn't matter, the answer, when you put in the calculator, is the same. O sea, suppose que yo apply log. One more time, we apply the property number 7, que allow us this exponent go to the front. And this is now is no exponential equation anymore. This is linear equation. And you solving exactly the same, you solving this stupid equation. 2x equals 4 divided by 2, because my unknown is not in the exponent. This is completely different to this. Okay? Now divided by logarithm of both sides. Logarithm of 2 both sides. And x is equal the division log a over 5 inside the argument divided by log of 2. And this is my exact answer. But in the test, no. In the test, I want the approximate answer. The approximate answer. Then I put in my calculator, clear, log, inside the parenthesis, a divided by 5, close the parenthesis. Division, logarithm again, of 2. Close the parenthesis and present. Bam! I got it. I have the answer. Exactly. It's 0.6781. I copied the 81, 80. 71905. I copy this, pero suppose que the test ask me 4 decimal place. This number is 7, is greater than 5, increasing 1, entonces 0.6781, exactly you say. Guys, I told you that today is the day to bring the calculator, because today we practice that. Okay? And from today, it's mandatory bring the calculator. And you don't pass this class without calculator. Definitely. Because we need to compute a logarithm and exponential, que is a special function, que it's impossible to do it by hand. In the majority of the case, it's impossible to do it by hand. Okay, let me try to solve one more complicated. More complicated. Any question? I suppose that everyone follow me. Yes or no? It's hard or it's easy? Example 3. Okay, suppose this 0.3 raised to the 1 plus x. So 1 plus x is in the exponent part equal 1.7 is the another base raised to the 2x minus 1. This is completely special exponential equation because, you know, 0.3 and 1.7 never we can express it using common base. Okay, so the only possibility we have in my hand is computed using logarithm on both sides. Logarithm is magic. Logarithm allow me convert exponential equation to linear equation. And you solve the linear equation, and finally we finish with the calculator to compute the approximate answer. Okay, let's do it. Logarithm of both sides. Logarithm of both sides. Log of the 0.3 raised to the 1 plus x is equal log 1.7 raised to the 2x minus 1. Entonces en this case you apply the property number 7 twice. So this expression is 1 plus x. Go to the front. And this expression, 2x minus 1, go to the front. Entonces you write 1 plus x, parenthesis, log of 0.3. It's important that parenthesis, no? Because if you write without parentheses, suppose like that, this is wrong. Because I suppose that x multiply only the logarithm and 1 no. So this is completely wrong. This is multiplication, everything. And the right hand side, identical. 2x minus 1, log 1.7. In that moment, we have linear equation. No exponential equation anymore. And you proceed exactly the same we are doing in elementary. In elementary, no, in intermediate algebra. Okay, you remove parentheses, apply distributive properties. You consider, this is weird, but it's logical. This is just a number. I multiply by 1, I multiply by x. Entonces, log 0.3 plus x times log of 0.3. On the right hand side, identical. This and this, and this and that. So the 2x log of 1.7 minus log 1.7. Okay, what is my goal? My goal is solve for x. So in order to, okay, you, for example, this guy stay here, x log of 0.3. This now I move to the left. 1.7. Okay, this guy stay here minus logarithm 1.7. I bring logarithm 0.3 to the right hand side like a minus. Logarithm 0.3. Okay, and remember my goal is solve for x. I factorization x here. Entonces x out, factor out, factorization. So the great common factor is x. We have log 0.3 minus 2 log 1.7 is equal negative logarithm 1.7. Okay, before that. Okay, this is completely optional, no mandatory. Okay, I want to change a little bit because I don't like this equation. No? This equation contains too much negative. Well, the only guy gets positive is the first. Everything is negative. So if you multiply whole thing by -1, well, does this become positive? This is not mandatory, no? But I like that. To visualize much better this. X logarithm 0.3. And this is easy. Entonces logaritmo 1.7 plus logaritmo 0.3. Now it's easier to understand. Okay, now factorization. X is great common factor, 2 logarithm 1.7 minus logaritmo 0.3 es equal logaritmo 1.7 plus logaritmo 0.3. I forgot one parenthesis here. Now finally divide both sides by this factor, que es 2 logaritmo 1.7 minus logaritmo 0.3, both sides, 2 logaritmo 1.7 minus logaritmo 0.3. Entonces this is only x. This is my intention, of course. X, so for x, I did that. Is equal logaritmo 1.7 plus logaritmo 0.3 over 2 times logaritmo 1.7 minus logaritmo 0.3. This is perfect. We can put it in a calculator like that. However, no. I highly recommend do one process per first, que es condensing. O sea, no two logarithms en el calculator, only one. So I condensing these two logarithms in the top and only one. Entonces, using the property number 5. The property 5 say, when it's plus, it's multiplication. Pero multiplication what? Multiplication 1.7 times 0.3. Bang, 51. Where come from 0.51? Was the multiplication, I put in my calculator, 1.7 times 0.3. And the bottom, it's easier to put in the calculator, no two logarithms. In my opinion, no, I respect it. You can do it in any way. However, in the bottom, we condense it again, but you apply the property number 6 and property number 7. Because it's subtraction, entonces 1.7 square, because these two, using the property number 7, but backward, I put here, like it's pointing, divided by 0.3, everything inside the argument. I put in a calculator, like that. 1.7 square divided by 0.3. Is 9.6 repeated. So far I have this answer. Logarithm 0.51 divided by logarithm of 9.63 repeated, something like that. Okay, now I put in the calculator. Please help me. With the calculator, you put in it's easy. You put LOG, press the key LOG, 0.51. Close the parenthesis, divided by LOG, 9.63. And you trunk it like that. Boom. Wow. I get the weird answer. What's the answer? Help me. What is the answer? Es negative. Okay, es negative. Exactly. Caroline. Minus 0.2972976991. Suppose we need round using 4 decimal place. Entonces 73. Negative 0.2973. Because 9 increasing 1 this digit and negative. I want to take advantage of one idea. Okay, what is the reason? Let me try to interpretate. What is the reason that the answer is negative? The answer is negative because, look, in the top, we have inside the argument 0.51. If 51 is less than 1. Any logarithm of the number less than 1 is negative, automatically. And in the bottom, no. In the bottom, we have 9.63. And get greater than 1, and when you compare the logarithm is positive and negative divided by positive, the answer is negative. Be careful, guys. When the base, in this case we're using a standard base, no? And this standard base is 10 or e, both numbers are greater than 1, and when you put inside the argument of the logarithm number less than 1, the answer that the logarithm offers is negative. Si it's greater than 1, no, it's positive, of course. And remember, logarithms do not accept negative number and 0. This is completely out the domain. Logarithm of the negative 2, undefined. If you want to try, put in the calculator, and immediately the calculator say, no, 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 this is impossible. This is impossible. Okay? Any question? I know that this is a little bit hard. Sorry. Some people I hear in the in the college, no, I never understand logarithmic function, no? This is the most complicated part in college algebra. Any question? Any question? Everyone follow me or no? Okay. No? Clear? Confusing? Come on, come on. I want to hear opinion. Caroline, you did okay? John, Marta. Clear. Marta, Marta. I want to hear your opinion. Clear. Okay. Need to practice. Okay, okay. Okay, 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 okay. Listen to me. What is the regular way to practice? The Alex is waiting for you. Okay? You practice. When you're stuck in one question, immediately you reply me. You send me a message. Take a screenshot. I solving the problem. Yeah, I try. I need to work a bit more. Yeah, I know, I understand. Okay, okay. I understand very well. Let's try to do one more, at least one more example. Pero Wednesday we continue working in the same idea. Okay. Suppose this look like a little bit complicated. Example 4. Suppose 4 to the x power minus 10 times 4 to the minus x. Yes, thank you for always answering. No, 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 my pleasure, Ruth, my pleasure. Mira, Ruth, using this service. I don't know what is the doctor application. There are a lot of applications. Okay, when you put the equation, give you even the exponential and logarithmic the answer. But no, it's not funny, no. Maybe you can use in, but no, never you using that. But this is not illegal, no. Okay, suppose this equation. Wow, this equation look like weird. However, I don't like negative exponent. So I propose you multiplication, everything, the entire equation, by 4 to the x. Multiplication by 4 to the x. To the x, sorry. To the x. Because I know that when you multiply 4 to the x times the first, look, is 4 to the x times itself, no? It's a square. Minus 10 times 4 times 4 to the x. Ooh, this is 1. Because 4 to the minus x times 4 to the x is 4 to the minus x plus x, is 0. And any number raised to the 0 power is 1. A multiplication, this and this and this and that, no? Is 3 times 4 to the x. Okay, time. Okay, let me organize. This is 4 to the x squared minus 4 to the x I multiply to the left equal to 0. Because I realize that this equation is equation quadratic in 4. How do you know that? Because I see one expression raised to the second power and the same expression as this raised to the 1 power. So remember this equation we solving using the auxiliary variable u. So this is u squared minus 3u minus 10. Wow, quadratic equation now. Easy. By factorization, a piece of cake because the combination is 5 and 2, no? 5 and 2, 5 and 2, 5 and 2. 5 times 2 is 10. 5 minus 2 is 3, negative 5, and positive 2. So the solution is 2 solution, u equal 5, and u equal negative 2 is the solution for that part. And u value, I need x value, pero the connection between u and x is this formula. Entonces es 4 to the x power equal 5, and 4 to the x power is equal minus 2. In this moment, we have two new exponential equations. And this exponential equation obviously are special because 5 and 4 never matching very well. And you apply logarithm on both sides. What kind? I don't know. I apply in my paper natural. You apply natural. And you apply the one more time the property 7. I put in the front. Okay, finally divided by ln of 4, ln of 5, divided by ln of 4. Okay, now you put in the calculator, you trunk it around to the 4 decimal place, and we have approximately, approximation, that symbol indicate approximation 1.1609. So we have two potential solutions because we have in the quadratic equation, we have two solutions. When you apply here logarithm on both sides, you have x logarithm of 4, exactly the same with this. Is equal logarithm of negative 2. Wow! But I know que logarithms do not accept negative number. This is completely undefined. That means that for the solution negative 2, we have no value, and the only solution in our problem is this. Keep in mind, guys. Keep in mind. Keep in mind. Keep in mind. Then the thing is, start working as soon as possible in the Alex part. Okay, by the way, this is the last chapter, no? The chapter 4. The chapter 4 includes the exponential, logarithmic, and their applications. Any question? No? Clear? Bye.
Thank you, Professor.
Pleasure anytime.